Okay, let's solve today's lead code problem of the day. 2126 destroying asteroids. Okay, so I have a mass and I have asteroids. I have to return a boolean. Alright. You're given an integer mass, sure, which represents the original mass of a planet. You're further given an integer of asteroids, where asteroid of I is the ith mass of the ith asteroids. Alright. So bunch of numbers and another number. You can arrange for the planet to collide with the asteroids in any arbitrary order. If the mass of the planet is greater than or equal to the mass of the asteroid is destroyed, and the planet gains the mass of the asteroid. Otherwise, the planet is destroyed. Return if all asteroids can be destroyed. Otherwise, return false. So return true if all the asteroids can be destroyed. Otherwise, you can return a false. Okay, so m is the mass of the planet. These are the asteroids. If this value is greater than ith value of this, I can destroy this value. I mean, take that this entire value into the mass. I see. And then I have to see if this array can be emptied or not. But technically, I can just sort it. We just sort everything. ASTROIDS. That's correct. The idea is I can just sort everything and and then what? I can just start traversing from the end because it says I can do it in any arbitrary order. That's what's in any arbitrary order. Arbitrary order basically means random order. Like any order doesn't matter. Asteroids. You sort this and you go for int I equals to n minus 1, I greater than equal to 0, I minus minus. If the mass is greater than, does it say strictly greater than or equal to? Okay. So if it is greater than equal to asteroids of I hope the spelling is correct. Then what will happen? Then the mass will gain and the planet will gain the mass. Alright, so the planet is now going to gain this mass. Asteroids of and asteroid of I would be equal to 0. Else, C out, not C out. You just system dot out or just return a false. Don't even do anything. You return a false. If this is executed, you return a true. I think this is the best way to solve it. I don't know what's the spelling of return apparently. Return. This passed and this failed. The answer was false. Okay. This must be a false already. So the initial mass was 10. Or maybe I should just do it then by like this. Just go from the smallest and destroy them first. And that would help me gain the mass. I think this should work. Minus 1, what? Why minus minus? This should be plus plus. Works. But can I do it in log of, like in linear time is my question. Wrong answer on test case 66. Did it overflow? I think it did. I don't think it would have overflowed. What's the constraints? 10 to the power of 5. That's 10,000. Is it 10,000? That's about 100,000, 10,000. You have 10, 100, 1,000, 10,000. I mean, this should work. Then what went wrong? We just do long answer is equal to mass. And I can say answer, answer, and try this. I don't think it was due to the fact. Oh, it was overflowing. That makes sense. So yeah, the idea of solving this problem is actually very simple. Because I have sorted the array, what happens is that all the asteroids with the smallest weight accumulate in the front. Like that's how sorting works. You take the smallest elements and place them in the front, and then the bigger elements start going towards the right. That's how sorting works. So the idea is that if I can first start destroying the smaller asteroids, I will gain their masses, which will overall increase the overall mass of the planet. Like the planet is supposed to destroy the asteroids which are less than or equal to its mass. If I and After destroying them, it will take their weight and add it to itself. I don't know what kind of black magic is that, but that's how it is. Now I'm thinking how to do it in linear time because this works. This is the best kind of greedy solution you can do for this. What are the topics? Let's say array greedy sorting. Okay. Can you do it and consider the can greedy an asteroid if it will destroy the planet? So sorting was the optimal solution for this. And I have to keep in mind this overflow condition because I think the length of the array kind of matters because you can have 10 to the power of 5 elements and each of those elements can be also 10 to the power 5. So you do some maths and it's greater than the integer limit. That's cool. So yeah, that's the problem solved. Simple. You just sort the array. You destroy the smaller asteroids first and add the mass to the planet. And just keep after every iteration, you just keep checking whether the condition holds or not. Because we have any arbitrary order, we can sort it and then we can pick out the asteroids and check for our condition. So pretty simple. And also the long thing, I just explained the long thing, you just store the answer in the long. Simply because it can overflow. Like you have 10 to the power 5 elements, and each of those elements can themselves be 10 to the power of 5. Uh, you just keep adding them over and over again, and they are going to overflow. So that is why to avoid this, you can do that. Otherwise, the problem was well simple, nothing new. What's the acceptance rate? 857%. That's interesting. So yeah, simple.